Welcome everyone to another low-level C programming video. I hope you learned something. In yesterday's episode, here is our Linux distribution, T2, just mostly raw, somewhat unpatched Linux. We have our C preload library for file list tracking. It's a little bit low-tech or medium-tech. At least it's high performance. It's of course not security related for security because you could simply LD preload that away. But for us, we only want to track and very fastly, so installed files, and that is fine. So yesterday we've seen a really bizarre and C thing that after using this 20 years, it failed with wine, and with some quick guru meditation yesterday. One second. So we have seen we used string talk here, and after some quick guru meditation we found out that wine, some wine resource tool must use that too, so that of course wine other user code does not expect opening a file to modify the string talk state. String talk being a string tokenizing function, a very 30-40-year-old function. So, and I changed this to the thread safe version here with this pointer state, and so far so good, right? You can watch yesterday's video, but I wanted to say, actually, after the live stream I saw somehow this is a little bit nah, because not only this is a little bit wasteful, and so much too, you write it and see it's high performance, nah. Sort of, as people troll me in the YouTube comments of like, yeah, C++ is not fast enough. Of course C++ can be faster, right? If you write more amazing code, better algorithms and stuff. And strings, for example, string length is O(n) in C, and that is O1. Actually, I should, big O notation, I should actually know that. And I hope it is, no, it's not that, thank you very much. I think it's O, so I wanted that O1, right? Or what is that? Example, or do I want, all I wanted is, where do they have that? Or something, yeah, constant, O1. Of course it is. Just wanted to fact check that, not that we distribute here. Spread some nonsense. Anyway, so because C++ STL strings have a size, so so much to super trial, right? Constant O1 versus ON. I mean, of course, C++ is more amazing, right? Anyway, so I thought yesterday, yeah, but we fixed this, it works. But then I thought, yeah, somehow, you know what? This is a little bit shabby here, right? We can do better, because first of all, we string copy this, because the problem is string talk modifies the string. So you have a constant string of your filtering directories, and then you need to copy it, because you can't string talk that twice, right? So you have the second call. This is why we had to copy that here. And then each time we string talk it and said, nah, you know what, we certainly can do better than that. Better than that would be to do that once, right? String talk that only once. Why tokenize the string each time some file operation occurs? And I've done that last night at midnight, my famous with the wine on the couch at home stuff. So I modified this here last night to have an array, a hard-coded size of 16. It's like, yeah, and basically at initialization, string talk this once and store an array of directories, filter directories, that avoids a copy. So we save, the filter pairs is some 100. So we save copying hundreds. It's not a 386, sure, it's epic thread ripping, right? Or an SG Octane. But still, we copy 100 bytes, hundreds of bytes, depending on where you build T2, on each file operation, and we string talk this. So we copy the string, and then we scan the string, and then we string compare the string. It's like, yeah, C, totally amazing programming, right? High performance. And so I changed this to pre-compute this pointers to the string talks at once. Don't copy it. String talk at once. String tokenize at once. Store the pointers to the filter directories. Their initialization time, so just split the filter dir for copies at once, because I think we need to copy. I guess the environment could be modified theoretically by programs. So if we wouldn't copy, but only once, right? Not in each open operation. I think this is also C programming, right? So you need to copy something because your program can also modify the environment, right? I would think if you put env a new string, if the program we intercept modifies the environment, I would think the pointer could go out of bounds, probably. So better still copy it. It's a rare situation, but we don't want this stuff randomly crashing next year, right? String talks as ones, saves as pointers, and null terminates as pointers. And then at the each file operation, you handle file access after in our sandboxing stuff. Instead of string tokenizing that here, only for I to filter ds, string compare that. So the code is much more cleaner, as you probably agree, right? But don't quit this video just yet, because that was slower, right? You optimize, also yeah, micro optimization, right? You optimize the stuff, well, at least the code is cleaner, right? It's freaking slower. So this is my reference time last night here on an Ryzen 5950X without reboot. I think reboot could probably change the memory timing, training stuff, potentially could also. Yeah, benchmarking. Also, I'm aware, pro tip, theoretically we should benchmark that on a fixed frequency thing, not a modern. I wonder if you can totally, if you disable performance boost optimization on Ryzen or Intel. It's like, yeah, otherwise use a totally fixed clock CPU, because otherwise benchmarking, you benchmark your thermals and your boosting behavior and stuff. And we see that here, right? So this is my reference time. This is the old code that copied the string for each file access. Yes, in the grand scheme of schemes, this is total micro optimization, as you see here, right? But I thought as we touched that already in 2022, we make it a little bit nicer. And it's a total, building the Linux kernel, of course, we have millions of file accesses, right? So it's not a nothing burger. It's a tiny little bit, right? But of course, the system call overhead of syscall, the Linux kernel of doing all the file handling, of course, that is a magnitude more than our tiny 100 bytes of string copy and tokenizing. But nonetheless, other people overclock their Ryzen 4s, right? So that is a reference time. That are 3 builds. So this is a new code, and it's like, yeah, it's like a freaking half a second slower, right? More, even run it 3 times. So this is a real wall clock time with a total otherwise idle Ryzen 5950X. And this is real, this is user. So wall clock time is of course less than accumulated user time, because we epic thread rip that with 32 threads. So that is of course multiplied by nearly 32. And as you see here, our user time is more. Yeah, 3 times, even more here. So my guess is we could performance counter that. Micro optimize the heck out of it. I guess the overhead is that it is even this massive caches of 32 or so total L1, L2, L3 combined caches here on this Ryzen. It is some pointers, also your caches, registers. It's tiny little. It's like, it sounds 386 like of, hey, 16 freaking pointers, right? Or up to, I mean, we are using 3, right? We only iterate 3 tokens here. But it is crazy. I found it crazy. I expected, that's also the stuff, right? Benchmark it, right? If you didn't benchmark it, you don't optimize it, right? You random guess. And if you micro benchmark stuff, well, first of all, this was mostly pointless to micro benchmark because of the sheer, yeah, this is not a hot path, right? This is not, but nonetheless, making this code nicer would be preferable anyway. So yeah, benchmark, and more benchmark. There's no substitute for benchmark than more benchmark. And don't commit stuff that's slower, right? Obviously. So it can only be, because so we only tokenize it once, and we don't string copy this. So the overhead of this pointers of using registers and additional caches for, also these are 60 freaking bit pointers, right? If you wonder why for the P3 and Spark we built for 32-bit userland, because pointers, right? So up to, although we are only using 3, although we are using 4 because we need the zero termination. So we have 3 filter tokens plus a 0 Sentinel. 4 freaking pointers, 4 times 64-bit, but that adds up a little bit, right? And I'm surprised that this is benchmarkable, to be honest. And of course we can do better than that. It's like, yeah, okay, that sucks. Night time spent for nothing. Can we do better? Yes, of course we can do better. So I was like, yeah, okay, we can do even better. So the new version, I improved it even further. Then I thought, I went to bed and stuff, fed Junior and changed diapers and stuff. And it's like, yeah, wait a second, why store pointers, right? I mean, we waste all the additional time here for pointers. Then don't store the pointers, right? Still copy it once, copy get env here of filter dir of our FL wrapper filter dir, and still pre-tokenize that here once. Also nice for loop, right? For loop with using here initializer, string talk stuff, and then an empty for loop body for this tokenizing. So we still tokenize that, and the point of that is that we have a zero termination. But we for string compare in the file access we need to replace the colon, our directory path separator. We need to null terminate all those strings, and then we need an extra null terminator because it's this. So basically getting rid of this additional array to store the pointers and scan all the tokens linearly, but without the copy and without the string retokenizing. That surely must be faster, right? And the only thing we need additional, unfortunately, because C strings are not constant, that sucks a little bit here, of course. We first need to freaking pre-scan this bloody string. I was thinking theoretically we could. This, of course, is a little bit wasteful, right? Again, people in my comments like, C is the most amazing invention since sliced bread and amazing stuff and stuff. Like, nah, here again, ON complexity of freaking string length, right? When we just freaking copied the bloody string and then we need to string length that shit again. So much to see totally high performance. I was thinking we could change the copy get env function here to actually have an additional zero termination, maybe theoretically, like copy get env and then an optional argument of freaking zero terminated stuff. Anyway, micro optimizations. So this changes with string talk tokenizes the colon separator to nulls and then additional zero termination of, theoretically that needs a little bit more bound checking, right? This is like, see, we got this. Basically we don't really, yeah, I mean, instead of the YouTube video, maybe I should actually properly bounds check that. We have here path max sizes, so usually we, like, yeah, usually security, usually we don't do that, right? Theoretically, we actually should check here the size, to be honest, but yeah, let's like see, we got this. Yeah. Anyway, maybe I do this another night. So for this extra null terminating, so this is a list of strings now, a string list, and we need this additional marker. We need to introduce additional marker here of string length of this original filter dir here +2 and yeah, bound checking, right? So this is our additional zero terminate list thing. And as I outlined, because he's not amazing, that could be one string length more efficient. And then the filter dir here changes, instead of string talk or this pointers, then we use this filter dir. We start comparing this filter directory list or t filter dir here, and then we get the lengths. And this is why we null terminate the list, right? The last length will be 0. So use a length variable here of each string length. And yeah, again, bloody pre-scanning the bloody strings, even if they don't compare and stuff. But yeah, see performance, so didn't get that. And then we iterate here the filter. So instead of the pointers, simply the string length we needed anyway for string and compare here. And so that combines getting rid of an extra string copy, string tokenizing, combines the best of the worlds. That is like, sure, you can do it in each way, but some ways are a little bit more micro optimized than others. Here, of course, string length +1 because that is the zero termination of the strings. And yeah, this is tiny little bit faster. So this is original code. So this is 0. Like a million or more file accesses in the Linux kernel, comparing each file access with. This is even performance optimization, right? The filter directory stuff for temp and the build directory. This is actually purely a performance optimization to start with, because 15 years ago or 18 years ago, I noticed that also we run into file size limits, right? Back in the day, 18 years ago, when file size were usually with large file support, I think 2 GB or so. For those who are new to this stuff on most Unixes and Linux, 2 GB, I guess, file size limit, large file size. And with some builds, at least OpenOffice, maybe the Linux kernel Firefox, but maybe with OpenOffice first, monstrous code bases, right? We run into our file list log for sandbox stuff to reach 2 GB, right? So large, 18 years ago, the builds already were of stuff. And then due to that, I noticed, yeah, guru meditating, that I thought 18 years ago, like, yeah, why do we save all the stuff that we need? Also, we need to post-process, right? We need to check for the dependencies and installed files. So first we write 2 GB or more of logs, which we now filter, and then only later to filter it out. So this is why 18 years ago, this was a performance optimization to start with. Yeah, so a tiny little bit faster. Of course, it's not us like, yeah, boosting and stuff. It's like, yeah, the first thing was faster, so much to epic thread ripping Horizon and variable processor frequencies. To do this totally scientific, you, as I mentioned in the beginning of this video, you would need to fixed clock, no CPU frequency scaling for this stuff. But yeah, the first build was faster, 125, although the user time is a little bit, yeah, at least the wall clock time was faster, and then 120. Yeah, so much to benchmarking random shit. At least it's mostly, yeah, it's a micro optimization. At least the code is more readable. So like, yeah, we tiny little bit maybe faster. It should be a little bit faster, right? It's probably my liquid cooling running warm here. But again, it's not like the hottest path of all the compilation of all the system codes. Of course, everything is more expensive than that. I would say this code is also more elegant, except we still need to bounce check there a little bit more, because in the other code from last night that I had somewhere, like maybe here, we had this fixed size array that of course was also not ideal here with the 16. Theoretically this should have been also, yeah, C programming, right? Because there is not amazing standard template library of crappy C runtime library. You don't even have like resizable. Sure, you could reallocate that. I was thinking like to do this really nice, you would need to, while scanning that, maybe reallocate that or something. This was the test, so my fixed size test was already slower. So, yeah. So due to that, getting rid of this fixed size erasing, this is of course not how you should do it. Nonetheless, how most C people usually do it. I would say this code is more elegant. Readability, nah, maybe it could be tiny little bit more readable, to be honest. It's of course a little bit, should we remove that? Anyway, maybe I don't like cluttering names all over this stuff. That was 18 years ago. Yeah, readability, this is a little bit advanced, right? Assigning that and using the L value here for size comparison. I mean, it's not like totally unheard of. I mean, this is of course what C programmers usually do. At least there is not an additional fixed size array thing. The only thing what we actually really should do is this path max thing here. And for that, I mean, very theoretically, I mean, it never failed so far. It would of course be nice at the bare minimum the stuff should error out, like, yeah, YOLO whatever, error, your user supplied filter directory stuff is longer than path max. I slightly wonder, so the thing is I can't benchmark via YouTube live stream. I only wonder if maybe I should actually commit this now, not to, if it would be measurable if we don't string length that stuff here, and I think string, what does string copy return? Does it return the end of the string? Also the stuff like most people don't know, right? I mean, unless you write C code every freaking day. I mean, I'm relatively good at this. It's just like this kind of unimportant stuff I also need to look up. Return value shall return a pointer to the terminating null character copied into the S1 buffer. Yeah, so we can use that directly. So this would be another tiny performance optimization. Maybe combine that. We probably should combine that with. Should we? You know what? Let's commit this first and to snapshot that. Comments. Matthew said, seen bread slicing machines and there's certainly better innovations than C. I totally agree. I don't even like the saying because sliced bread, if you mean with sliced bread, buying that in a store, then I don't like this because then usually this bread dries out faster. So yeah, I hate pre-sliced bread because they're getting old and untasty and stuff. I like to cut my bread myself, freaking fresh at home. Microkernel video coming soon, yes, of course. Working on this. I just happen to have to maintain the best Linux distribution, at least for me and my friends. So, cheers. So yeah, let's make this even a little bit better. Let's maybe commit this first. The only thing is benchmarking. I need to stop the live stream because even listening to MP3 already, web radio. So very theoretically, maybe we should text pause of wrapper. Where was this? We shouldn't. Yeah, I don't. This is inconsistent white spacing, but that is not the worst thing. Just we shouldn't randomly commit your stuff. Very theoretically, maybe we should also not change that. Actually, no. Let's just a tiny little bit clean this up. Filtered here. I only changed that. That was because we changed the more code, but theoretically we shouldn't. Yeah, thank you much. Filter dear path max and yeah, we copied that first. I only changed that. I think I changed this. I only changed this because we keep manipulating that. I try to keep that together. And we need to revert this abort thing there that I'm still not sure if I want to commit that like that. Maybe we don't, but split. What else do we have there? Filter dear. Yes, this was a copy. What's this copy? What is there? Oh, we need this length and micro optimize FL wrapper. So, right. Pair file and string copy and retoken. And then we could try to further filter de-optimize that. Not sure if Doug says string talk. Yeah, there is no point to using that. I'm back to that because we do this in initialization. This is in the constructor here, this ctor or yeah, attribute constructor. So we run this unthreaded before. This code was there already, so there we don't need that. So we don't need this extra pointer and state and stuff because we only do this once. We pre-tokenize that and then use it for the lifetime of the guest host program we allowed it into. So that is why back to using that because we don't redo that, right? And save a little bit. So let's maybe make this a little bit nicer. Size of like wlog and size of rlog, and although probably that is not measurable, but whatever. If the string length, let me just check. We have, if this doesn't have a string, we should have, should we, then the first, yeah, then the first string length is 0, that loop terminates there, okay. So filter dir and terminate that, and so that avoids this thing here. Then if we implement that, let's for now, so we would need here to do string uncopy, and that would be, should we use int? Probably int is fine, huh? Max lang or so, and terminate term. So get that, if we have that, so we would, let's see, that would be here. And yeah, inconsistent spacing, don't like the space here. And here's our pointer, character star end. Can we use end, or is it a special? Or two? No. Something of that sort. And then, so that is the termination, and let's move that in here directly. I hate copy and paste in Wayland, only working every second time for me this way. And so if we should terminate this additionally for our filter dir thing, then var2, so I need to check, so that should be that basically one more here, that should be out. Maybe we, now that we have some more code, I'm actually not liking this imbalance of something like that. I would say, also now we touched this, theoretically my preferred spacing is probably that. Does it make sense? Yeah, in C we could, of course, I usually prefer to keep it in my opinion, that is, yeah, I think that is more readable, right one. Theoretically, we should check the same max length thing there. It's probably not measurable, it's just mostly, I mean, at this point, this is only micro over optimization of stuff that you for sure can't measure. So does it make sense? If we got an environment variable, then freaking copy it. If we should terminate that, then var2 one further, because this is basically creating. Actually, you know what? Theoretic. Oh, wait a second. We could even, because we don't even. You know what? We don't need a variable. We can just use that one. And I only wonder if theoretically would this slightly be nicer if... Ah, darn. Did I say that? Ah, darn. You know what? With this kind of code, we could even leave it like it originally was if we don't need more. I think this is even nicer to read, I would say. It only needs... and then var1. So if we didn't get an environment, this is only changing for the rare case, which usually shouldn't happen. We didn't get an environment variable. We have enough space anyway. Then this is just 1, 0 null terminating sentinel there. Of course, we have with path max always space to store that. I mean, given the style, we could even use the same style, and so that works in either case. We only need to check the max path there eventually. So yeah, that could be even. Maybe we should actually let's test that. It was 1. So yeah, to benchmark that, it's mostly pointless. It's just like making it nicer while we can showing you. Hopefully people get some tips and tricks how to write even more amazing C code, which, like, yeah, of course, C code is never amazing. So, but if you wanted to and write proper C code, that is how you write more proper C code. So we want to quickly debug that, see if that makes still some sense. Oops. Just rebuilding our sandboxing with debugging stuff. So, okay, that didn't work apparently because we screwed something up. Yeah, somehow the filter here, so something doesn't work anymore. Good that we tested that. So yeah, there's no substitution for testing, except more testing. What would break now? What did we screw up? Maybe we div that of size of 001. Not terminate, and I think string talk, so that is string length. So we could have only messed up this thing here. Get inf var, and if maybe we don't terminate that properly. We can't super easily debug that with a debugger because we preload that. That is a little bit more. Printf to debug or other good meditation. But nothing like one printf should be able to debug. Okay, this is the first thing. So apparently we terminate this wrong. Apparently terminates the first string copy. What is this one string copy? Did we return the pointer to the terminating null character copied into the S1 buffer? What? STP copy. We STP copied that wrong. We used the wrong function because I overlooked that. Does there exist STP and copy? STP and copy even exists. Amazing. There, fixed that. So that hopefully fixes that issue. Let's see, temp. Okay, that works. That is properly handled, and that is temp source. That also works, and then cargo home of due to filter here. So here that apparently checks all out. Also, yeah, did you know that there's an STP copy? Obviously not. The only, yeah, will it be measurable? Nah, we will see. So maybe it makes it more measurable. Although, yeah, it's one strict copy. Probably not. Anyway, a little bit nicer code. We need to handle this size here anyway. So that would be string SDPN CPY of max lang, and the only thing is, so that is a little bit annoying to handle. Because it doesn't null terminate. This is, yeah, C security bond checking, they totally got that right. So that is the N family of, is that here the, yada. Shall copy not more than N bytes, bytes that follow a null character are not copied from the array pointer pointed to by S2 to the array pointed to by S1. If the array pointed to by S2 is a string that is shorter, null character shall be appended to the copy in the array pointed to S1 until N bytes are all written. If where is even? Does he not mention that? Must provide space. Shall ensure that S2 do not overlap. From different combinations. Surprises. Oh, so yeah, C implementation defined behavior, right? Overlapping moves may yield surprises. If there is no null character byte in the first N bytes pointed to S2, the result is in not null terminated. So this surprises many even advanced C programmers and also led to a couple of security vulnerabilities already, right? So these APIs are not foolproof. Probably should have been slightly more amazing. It's somewhat crazy that using the more secure size limited copy functions, you can end up with not null terminated things. So yeah, we would need to check that. Basically, probably the easiest thing to check if the string returned by string STP copy that we use is like pre-compute the last valid byte and check whether we reached that. That is probably the otherwise the other string, but string and copy they return. If a null character is written to the destination, shall return the address of the which are to be even string. Wait, does it return different if a null character is written to the destination? This STP. Why are we? Okay, string and copy always returns as ones. Like, yeah, not the super most useful. Otherwise, it shall return S1n, the address of S1n. So yeah, we can simply pre-compute the last valid address and check if we are at that address and it's not null terminated and abort with YOLO, whatever your stuff is long. Anyway, Isn't it amazing? C, totally most amazing stuff in 2022, right? And yeah, I will do some final benchmarking run. As a size check, that is certainly more useful. Mostly, it's of course not really security related. I mostly want to know if, otherwise, if I don't do it now, I will forget for the next decade, and then I will have a surprise building some crazy stuff and randomly have memory corruption, because yeah, C, you at least get random memory corruption because bounce checks and stuff, right? Anyway, hope you learned something, especially yeah, even such travel stuff you can even improve upon and stuff. And hope you share, like, and subscribe, and to see you soon for all the next fun stuff to come.